Let's consider the circuit above. We are asked to find what the total resistance of this network. And from this circuit, these resistors, 3 ohm resistor, 4 ohms, and 2 ohm resistors, they are all connected in what? Series. Why are they in series? Because the same current will flow through the 3 of them. The same current will flow through the what? The 3 of them. So since they are in series, we will have that 3 ohms, 4 ohms, and 2 ohms are in what? Series. They are in series. So we have that the equivalent resistance will now equals to what? 3 plus 4 plus 2. 3 plus 4 plus 2, which will equals to what? 9 ohms. So we can now draw the word circuit. Our first withdrawal will be, this will be our first withdrawal. Our first withdrawal so we have 3 ohms, we have 2 ohms, we have 2 ohms, we have 5 ohms, we have 3 ohms, we have 3 ohms, and the total resistance, which is the equivalent resistance of these 3, is 9 ohms. So at this point, these 2 resistors are in what? Parallel. Because what? Current will flow through this point and reach this node, reach this point and split. That is why they are in what? Parallel. So the equivalent resistance, the 3 ohms, that is called the 3 ohms and 9 ohms resistors are in what? In parallel. Which can be written as 3 is in parallel with what? The 9 ohm resistors. Which will now equals to what? The equivalent resistance will be 3 times 9 divided by 3 plus 9. And 3 times 9 is 27. And 3 plus 9 is 12. So 27 divided by 12 from the calculator, 27 divided by 12 will give me 2.25 ohms. 2.25 ohms. So this is the what? The equivalent resistance of these 2 networks. We are going to withdraw. Our second withdrawal will be, we will have our second withdrawal as this. This will be our second withdrawal. And we will have another resistor here. Since these 2 are in parallel, which is what we just calculated here, it will be in this form. So it will be 2.25 ohms. This will be what? 2 ohms. Here will be 3 ohms. Here will be 5 ohms. This will be what? 3 ohms. And here will be what? 2 ohms. And from this, our second withdrawal, this resistor, these 2 ohm resistor, 2.25 resistor, and 3 ohm resistors are in what? Parallel. They are in series. Because the same current will flow through what? The 3 of them. So we have our what? The total resistance now. Let me wipe. The total resistance now of that network, the equivalent resistance of these 3 resistors, 2 ohms, 2.25 ohms, and what? And 3 ohms are in what? Series. So therefore, the equivalent resistance will be what? 2 plus 2.5 plus 3. So the total resistance will be 2 plus 2.25 plus 3 will be what? 7.25 ohms. So that is the equivalent resistance of these 3 resistors. So we have our third withdrawal, which will be, here will be our third withdrawal. Sorry. This will be our third withdrawal. So here is our third withdrawal. Here is 3 ohms. Here is 2 ohms. Here is 5 ohms. And this will be what? 7.25 ohms. 7.25 ohms. And from this, our third withdrawal, this 5 ohm resistor and 7.25 ohm resistors are in what? Parallel. They are in what? Parallel. So since they are in parallel, our equivalent resistance of that 2 resistors which are in parallel will be what? 5 ohms. 5 ohms is in parallel with what? 7.25 ohm. So the equivalent resistance will be equal to what? 5 times 7.25 divided by 5 plus 7.25, which will equal to 5, from my calculator, 5 times 7.25 is 36.25 all over what? 5 plus 7.25 is 12.25. So the equivalent distance will now equal to 36.25 divided by what? 12.25, which is what? 2.96 ohms. So we can now draw. So that is the equivalent resistance of these 2 parallel elements. So we have our our fourth withdrawal. We have our fourth withdrawal. Our first withdrawal will be, the circuit will now be in this form. We have reduced the circuit now to a single series network. So here is 3 ohms. Here is here will be what? 2.96. Here will be what? 2 ohms. So at this point, these 3 ohm resistors, are in what? Series, because the same amount of current will flow through what? These 3 resistors. So the total resistance, which is the equivalent resistance of this complex network, will now equals to 3 plus 2.96 plus 2 ohms. Are you seeing? So 3 plus 2 is 5. 5 plus 2 is 7. So it will be what? 7.96 ohms. So this is the total, the equivalent resistance of this network. If you are watched to this extent, do well to like this video and leave a comment in the comment section if my explanation was helpful, and don't forget to subscribe to this channel so that whenever I upload a simplified video like this, you will be notified.